Hi guys, it's Miss Burns here. We're going to start off by looking at Chapter 1, and we're going to go quickly through Chapter 1 and just kind of get an overview of what we mean when we talk about statistics and some of the big ideas of what we're going to look at while we're in this class. So first of all, when we talk about statistics, we're always working with data. So what do we mean by data? Data are observations that are recorded. So anytime we look at a phenomena of some kind and we take observations that we write down, keep track of, take note of, whatever, those observations make up our data. And so statistics is the science, can be thought of as a science of collecting, organizing, that's a big piece of the puzzle, organizing, summarizing, and analyzing the data that we collect. And then once we've done that, we've taken that data, we've organized it, summarized it, and made some kind of analysis on it, we use that analysis to answer a question or draw some kind of conclusion. And so in this course, we'll focus on different types of data and the methods for collecting that data. So why is statistics important? Why do we care about statistics? Well, knowing statistics and being able to work with statistics allows us to explore the world, so the world around us. Obviously, with the pandemic going on right now, data and statistics is everywhere, and we're using that to drive a lot of decisions. So this is a really important topic for us. Statistics allows us to use evidence to check whether beliefs are true. And it's kind of hard to write on this stylus. I'm sorry, my handwriting is a little bit messy. Hopefully it'll get better as we go. But when we work with statistics, we want to be able to have some sort of evidence to support our beliefs, either to check to see if our beliefs are true or false or whatever. We use statistics to find patterns, and those patterns may lead us to new discoveries. And then finally to share those discoveries with others. So again, think about the pandemic and how different countries have gathered all this data and how they've worked together with that data and those analyses to help make decisions, and what things they've discovered about the coronavirus and things like that. And so that's really why we need to know about statistics. Keep in mind that statistics, I'm going to abbreviate, I'm going to say stats, must be used carefully. Knowing how the data was collected is a really, really important piece of the puzzle in knowing whether we can trust that data and trust those statistics. And we'll talk more as we go through the course about what we mean by using it carefully. Inappropriate use. So inappropriate use of statistics, inappropriate use may lead to inaccurate beliefs. Okay? And then, of course, when we have statistics and whatever conclusions we draw from those statistics, the results are always uncertain. And as we go through the course, we'll talk more about all of this and what we mean by uncertain. But there's always some uncertainty when we have statistics and we make a conclusion. There's always a little bit of uncertainty. Statisticians will always tell you that nothing is 100% sure every time. So we always have to kind of take everything with a grain of salt when we look at it. So statistics rest on two major concepts. The first we're going to talk about is variation. So you can think of variation as differences. So differences. Let's see, how can we phrase this? Differences in an item from others in the group. And again, I'm sorry, my handwriting's a little messy. I think it'll get better as we go here. So differences in literally what we mean, variations from one item to the next in a group. So a quick, simple example here. Consider the differences between the circles in the top row and the circles in the bottom row. Which one appears to have more variation? Hopefully you would agree that the top row looks like it's got more variation from one circle to the next compared to the 3 that are in the bottom row. And it says the top row circles were drawn by hand, so there's a little bit more variation because of that, whereas the bottom row circles were traced around a coin. All right. The other major part of statistics, or other piece that we want to look at, is the data itself. Okay. So remember that data are observations that we use to draw conclusions. That's the whole purpose of why we work with statistics, is to be able to make conclusions about some kind of data. The context for the data is essential. So context is essential. In what context are we using the data? What were the measurements? Or what units, I guess I should say. So take a look at this next example. If I just gave you these 4 numbers and I didn't tell you anything else, you'd be pretty confused. What do these numbers represent? They could represent a lot of different things, right? I'm just off the top of my head, I'm thinking they could represent weights. They could represent lengths. They could represent millions of people. Who knows? We don't know. So the units really matter here, and that's what I mean by context. So whenever you talk about data, you want to be sure that you're clear on what that data, what context that data was pulled from, what units you're using for those measurements, or whatever. You always want to be really clear about that data. So data analysis can be thought of as the process of examining collected data to look for patterns or numerical indicators that tell us the essence of what the data is really, or capture the essence of what the data is really trying to tell us. So data analysis is that process of pulling that data together and doing something with it to draw those conclusions. So the next section, we're going on to 1.2, is on classifying and storing data, and we're going to get a little bit more into what types of data we mean. A couple of terms here. Population, first of all, you've probably heard that term before somewhere in your history, but what we mean in this context, the population can be thought of as the collection of all, and I'm going to underline the word all data values that are possible for a particular group. Okay, so the population would be all possible data values that would be a part of a particular group. This is often difficult and sometimes impossible to obtain this information. If you think about a simple example, just think about voting. If our population in an election, let's say, is all of the voters in the United States, it's difficult before an election, really it's impossible before an election, to find out the opinions maybe of all the voters in the United States, an entire population. So what we do instead is we select a sample. So a sample can be thought of as a subset of the population. I really like that term, subset, because a sample is supposed to represent the population. So the sample should represent the population. Okay? And what I mean by represent, it should be in similar makeup of the population. If my population of voters, let's say again, is all of the voters in the United States, and let's say I only take a sample of Republicans, then I haven't really captured the entire population, because we know we have other political parties represented. So when you pull a sample from a population, it should be representative of that population in general. And we'll talk more about this later in the course. A sample is usually easier or sometimes the only thing you can obtain, and we have to use that sample to make some kind of generalization to the population. So a quick example here. Suppose you want to know what the predominant eye color in your country is. You survey a random sample of 2,500 people in your country, asking them about their eye color. So first of all, who is the population? Who are we interested in studying? Well, we're trying to find out the predominant eye color for my country. So the population would be everyone in the country. And of course, if you think about the practicality of this, I can't go around and ask every single person in my country what their eye color is. So instead, I'm going to pull a sample. And so in this case, I survey a random sample of 2,500 people in my country. So my sample is the 2,500 people that were surveyed. Okay, and then the data is what we asked them, the information we collected from them. So the data that we collected would have been their eye color. Okay, so just a simple example there of what we mean by population, and then the sample from that population. So that's the 2,500 people is the subset of the original population. All right, let's take a look at a little bit more in depth about classifying data. So the variable might be the characteristic of the data that's being collected. So in that last example, the eye color would have been the variable. There are two general types of variables, and statisticians can get a little more in depth than this, but in our course we're going to just basically categorize everything as one of these two types. So one type of variable that we might work with is called categorical variables. So a categorical variable describes a quality or a class of some kind. So for example, eye color, that would be a categorical variable. You could have blue eyes, brown eyes, green eyes, hazel eyes, whatever. Letter grades would be a categorical variable. An A, a B, a C. You're classifying everybody into some sort of category, I guess. So we could say letter grades, like an A for a class, or a B or a C. One thing to note about categorical variables is that they may include numbers. However, no arithmetic would be possible on those numbers. So if you think of like area codes is a good example of a categorical variable that includes numbers. Area codes, we're in Jacksonville, we're in the 904 area code. 813 is another area code. 704 is an area code. 352, we have all these different area codes. And those area codes represent basically where somebody lives or where that phone number is classified. However, can I do arithmetic? In other words, would it make sense for me to find an average of all the area codes? No, that wouldn't make any sense, because even though they have numbers in them, they're representing some sort of classification. So for that reason, they would be considered categorical variables. The other type of data we're going to work with are numerical variables. So for us, everything is going to either be classified as categorical or numerical. So when we talk about a numerical type of variable, that represents some sort of quantity of some kind, or a measurement of some kind. So any kind of measurement, sorry, that's such a mess. Measurement's that word. So any kind of measurement would be a numerical variable. For example, temperature, the temperature in the air. That's a measurement of the air temperature. So that would be a numerical variable. Height, someone's height, that's a measurement. That would be numerical. Shoe size might be numerical. Weight might be numerical. Things like that. So, and again, numerical variables, think about, can arithmetic be done? So like think about heights. If I surveyed everybody at Flagler College, or a sample maybe of heights at Flagler College, would it make sense to compute an average height? If it makes sense to compute, I always go back to average, because I think most of us have heard of an average. We can think of what an average number is. If it makes sense to compute an average for that variable, then that means we're dealing with a numerical variable. So take a look at this chart below. Classify the following variables as either numerical or categorical. So the height of a building, well, that's a measurement, so that would be numerical. And then letter grade on a test, so that would be some sort of classification, so that's categorical. Hours of sleep each night, so the number of hours of sleep you get, 5, 6, 7, could be 7.5, could be 3.5, depends maybe on how we're setting up the survey, but would it make sense to compute an average number of hours of sleep? The answer is yes, so that would be a numerical variable. Student GPAs, so that's numerical. It's a measurement of how you're doing in school. Types of cars, so whether I drive a Honda or a Nissan or whatever, those would be classifications of vehicles, so those would be categorical. Vegetable varieties planted in a garden, squash, zucchini, tomatoes, whatever, those would be categorical. However, if I look at the number of vegetable varieties planted in a garden, the numbers of varieties would be numerical. All right, so let's talk about other ways that we can look at data. Coded data. is another way we can store data. So using numbers to record categorical data. So occasionally you'll see something that's coded, categorical data. So it's using a number to record some sort of categorical data. And the point is to make the data a little bit easier to read. So as an example, let's say that we're talking about gender, and we're just going to say binary gender here. The gender is a male. We're going to say 1 for yes or 0 for no. I said binary. I guess this doesn't necessarily have to be a binary variable, but the point is if the person is a male, we say yes. If they are not, we say no. So yes, we're going to say is a 1 in the category, and no would be a 0 in the category. So if you look at your data here, we're looking at a sample of 1, 2, 3, 4, 5, 6 people. So this represents 6 different people. And you can see that there are 3 people in the group who are males. So this would be an example of coded data. Another way we could look at data is by looking at stacked data. So data values in stacked data would be stored in a spreadsheet format. Each row contains data for a single individual, and there's an example of this on the next page, so hang on one second. So with stacked data, each row represents the data for a single individual. And the nice thing about stacked data is it allows us to store many variables in one chart. So take a look on the next page. Each row corresponds to a dog at a local shelter. So we've got stacked data here because we're looking at data according to rows, and each column represents a different variable. So how many variables are there that we're looking at for the dogs at this shelter? We're looking at the weight, the gender, and whether or not they have some kind of illness. Notice we're using both categorical and numerical variables in the same table. So what are the 3 variables? Well, so we've got weight, that's one of them. Gender is another one. And then whether or not the dog has any kind of illness. How many dogs are represented in this sample? Well, remember with stacked data that each row represents an individual in the sample. So if you look at the number of rows we have, you can see that we have 1, 2, 3, 4, 5, 6. So there are 6 dogs represented in this particular sample. We could also have data that's unstacked. So with unstacked data, the data values are stored in 2 columns. And each column represents a different group. The thing with unstacked data is you can only store data for 2 groups. So these groups, you're a little bit more limited with unstacked data because you're only looking at 2 groups. The info in a row does not correspond to the same individual. So for this example, the table represents the average number of hours slept over a 1-week period for a sample of men and women. So how many people total are in this sample? Well, we've got 1, 2, 3, 4, 5, 6 men and 1, 2, 3, 4 women. So there's 10 people altogether that are looked at in this sample.